relatively longer. Like that could be the ship one, but
No, that's not one.
that's achievement right there.
It's just looking to the back.
This dude, they tried to call out the UN because he said something about the US something about climate change. He's like, climate change is real. This is like some high school kid that thinks he wants to
It tends to reorganize things.
Yeah, like calling out the UN. Everything he said about hyenas was wrong. So I just said, I responded to an area high school where it calls out the UN question mark, and he responds with, I have a friend from UW-AOS, I'm a national monitor.
I got just.
Or does not list with any imagery or pictures.
Yeah. Just for,
It's about
yeah.
flooding, just not-
I just want you to.
Yeah, I got some.
Oh, I can't, well, I can't read it anymore.
There's simulations.
You need me to drive it all or you good?
Oh my God, that's right.
No, I'm not gonna do much. I think I'm gonna look more at it.
Okay, let me know when you want.
Which is, I mean, it's nice because I was.
Okay.
We are ready to go, we're live and ready to go again.
Go ahead.
You're,
Got me there.
welcome to Weather Watch, Greg is gonna.
Welcome to Weather
We're
Watch.
going.
We're on. Yeah, John is not here today, so I'm gonna start Weather Watch off and then Michael will take over. But I thought I'd look a little bit at the Venice floods this week. There've been catastrophic flooding, I should say catastrophic, but serious flooding in Venice, the worst since 1966. And maybe it would be better to first look at Venice on Google Maps. And Venice is right about up here. It's at the mouth of the old mouth of the Po River Valley. Po River goes up into the Alps over here. The Alps are up in here, Milan's over in here, and then the Po River comes out here. And basically the entire Adriatic Sea here is like an extension of the Po Valley that comes up from Milan south of the Alps. So Venice is right in the middle there. When you zoom in on Venice.
What's with all the dead fish icons?
I don't know. It's something Google's putting in there.
It's weird.
Maybe it's some, I don't know. Let's get it close up here.
It's kind of creepy.
Okay, so you can see at the coast here, there's the kind of continental shelf out to about here. And then Venice is in this big lagoon here that's partially flooded. There's little islands in this marshy area where Venice is one of the, actually I think it occupies 5 of the islands that are hooked together. And so it's, you can see the landmass in here built into the island. And so Venice is an area that's vulnerable to flooding. They've built canals and they've built up on this island in the past 500 years or more. Actually, like 1,000 years, and people have lived there. And as you know, they use boats. They have water for the streets. There's some streets that you can walk on, but for the most part, it's an island with lots of little islands in the middle. So it's always somewhat vulnerable. And in the past few years, they've increase their vulnerability. There's been a sea level rise. Initially, the sea level rise was mostly from global warming. As the ocean warms, it expands, and that makes the height of the sea a little greater. But in recent years, the sea level rise has been more dominated by the melting glaciers. And so as sea level rises, it says in as of 12 or so, 2012, the sea had risen some large fraction of a meter over the years, and it's going to keep rising. So being a city at sea level, they've had more flooding during the tides. Now, in the Mediterranean area, the tides are not very high amplitude like they are through the rest of the world. They're fairly minuscule, but they're a little higher amplitude because of the Adriatic and the channeling of the flow up and down the Adriatic. So with the tides, they tend to get very close to flooding almost every day now. But when the tides are greater than normal, as they are during some times of the year, they get even more of a chance for tide. And I think they said they flood, there's some flooding in the streets hundreds of times per year. But this past week has been unusually high flooding. And I think I have, I took some, trying to get some of the online pictures of this.
Display mode, then click on it.
Oh, you're right, that's right.
It's on the main screen.
Okay. I'll just get it from here.
Here, it's up, Craig.
Oh, it is?
Yep.
Oh, it's up there?
Yep. You can look
Okay.
on this monitor over here too.
Yeah, I can't see it. All right, so this is just some examples of the pictures there. How do I click through this or move down, scroll through it? I can't see what I got. Is it on here where I scroll through it?
No.
So I have, oh, it's on here, okay. So I can go down.
That's your mouse.
Okay,
Yeah.
gotcha. I can see here inside of a building, you got the flooding and just a lot of devastation. I don't think we have to look at all these pictures to get the idea. But this is a pretty big deal there. And, you know, I guess they say a lot of hotels in Venice actually have boots for the patrons because the floods happen so often. But this is pretty unusual. This is the worst flooding since the 1600s, I believe, or it's 1865.
I saw
No.
something kind of ironic where apparently there was a city council meeting about acting on climate change.
Oh,
and
yeah.
Immediately after it concluded, they
Flooded, I saw that too.
and they voted to do nothing.
Well, there's actually two things that are happening. It's the sea levels rising, that's one of the main things, but the city itself is sinking. And it's, the reason the city is sinking is because it's in some kind of a river delta from Po River. It's in a delta and it's built on sediment, and the sediment is compressing over time. And to make it worse, they're pumping water out for their water. And so it's kind of like New Orleans is sinking, you know, they're sinking. And so that's part of it. Sea level rise is making it worse, and they're trying to do a number of engineering things to keep it from sinking, including not pumping water out of the aquifer underneath. But overall, it looks like a bad situation for the next 100 years or so as sea level rises. And we'll see more and more of these kind of pictures over time. So, have any of you ever been to Venice? It's a pretty cool place to go. It reminds me a lot of going to Disney World. And
Also,
because you have to pay an admission to get on the island. There's a train, you can't drive there. There's a train that takes you there, like the tram in Disney World. And you pay admission for the train. It's actually more than the train costs to go that distance. So it's like you're going to this place where you don't have your car and you can walk around through all these cool looking places, and it just feels like an amusement park instead of a real city. But it is kind of neat. There was actually.
Before you leave that page.
What's that?
Before you leave the page, I just wanted to note, I know it's probably gonna be part of your discussion, but this is the BBC News, page. But just their discussion beneath the picture is something that you rarely see in sort of popular news discussions, talking about the strong radial jet stream over across the northern hemisphere, conveyor belts. You see this in the New York Times, you don't see this in the Washington Post.
Yeah, you don't see that much detail in places, but But it is a weather situation in there, and we'll take a look at that. But again, I was saying, it is a cool place. I went to a conference there once and gave a talk in Venice, and we were on the Grand Canal, and they keep all the windows open there because it's the way they do it. They don't have air conditioning, they just keep the windows open. And while I was giving my talk, you could hear these people singing on the gondolas down below. And I actually, as I was giving my talk, I had to raise my voice because this guy was singing so loud. But it's just the kind of the environment there, and it's really a fun place to be. I don't think we need anything. Okay. I'll look very quickly. I tried to do some simulations of this, and they're not entirely successful at this point. This goes back to Tuesday morning. Actually, it's 6Z on Tuesday, so it would be 6 a.m. or actually probably 7 or 8 a.m. Venice time. And this is just a Vis 5D looking. You can see the height of the mountains, and that the Po Valley is in, or the Adriatic Sea is in this almost like a canyon relative to the Appian Mountains here, the Adriatic Mountains here, and then the Alps up in this region over here. And what you can see happening is this flow moving up the Adriatic, starting up the Adriatic here. And it's being driven by this rather strong cyclone that's over the Mediterranean between Sicily and Sardinia here. And in particular, what you see is this surge of winds coming from the south. This surge of winds coming from the south is called a Sakara. And the wind actually moves off of Africa over the desert. So the Saharan desert is very hot, has a deep boundary layer, and this very hot wind moves up into the Mediterranean. And because it's hot and the Mediterranean is warm, but it's relatively cool compared to that wind. So that creates a stable boundary layer. And because of the stable boundary layer, and I'm not getting the stable boundary layer because I don't have enough resolution in this run, vertical resolution to do it. So I'm not getting the effect. But what happens is the stable boundary layer traps the flow down low and raises the Froude number so that the flow cannot go over the mountains. It has to go around the mountains. And so what it does is it gets channeled up the Adriatic here. Now, when they see these coral winds coming, quite often they can look at the sky and it's like a red sky. It brings dust from the Sahara up there, and it's up above. But at low levels, they're in the marine boundary layer, and that traps the air down there and funnels these strong winds that are being created by the pressure gradient here up the Adriatic Sea. And we get a little of that in the simulation, but not enough because I'm not trapping the winds properly. See, they're going up there and they're actually going across and over the mountain. So that's not what's happening. The simulation is wrong, from what I can tell. We'll look at the more higher resolution of the GFS in the pivotal run. You can see much better what's happening there. But over the week, we've had several of these cyclones that are coming across the Mediterranean over here, and they keep bringing these Sakara winds up, and that's moving, piling water up the Adriatic. Formerly now, in the past decade or two, we call this effect of piling water up a basin like this a meteotsunami. And so this is a classic example of one of these meteotsunamis where you get persistent winds along this basin here that pile up the water on the end. We also have meteotsunamis they've been studying in Lake Michigan. Sometimes in Lake Michigan, you'll get air from the north in particular, and it'll pile water up on the south side and wreck some boat docks and things like that. It's become a fairly popular disaster topic to talk about in recent years. But this is probably one of the places where it's most crucial. So let's go ahead and get on the pivotal here. Pete,
Yeah.
let's look at the pivotal analysis.
Yes, I'm gonna go switch to the part.
Yeah, I'll just like to switch over. I think the pivotal, the analysis of the GFS on the pivotal looks very nice. You know what they don't have on pivotal? Is they don't have the ability to animate assimilated initial conditions.
Animate.
Well, why can't we just go back a week and just look at the initial conditions
I see.
animated rather than looking at old forecasts?
I think you can do an analysis link if you click on there.
Oh, can you? Okay.
Yeah, I think it's just called analysis link.
So the animation tab, it's a single image right now.
Well, let's not worry about it right now, but let's just look. We'll go back to the Tuesday 6-0 and do the surface winds. So this will show you the past week. This is the initial time here, and these cherry red places where the winds are real high. And you can see the winds coming up, the Adriatic here, and then circulating around this low, but coming off the Sahara Desert, and as they get funneled into this channel here, and they pick up speed, and they go up the Adriatic. Let's look at this now. It was Tuesday afternoon, I think, when some of these floods started getting very bad. You go through this.
We look at a little meso low right near Venice, right?
Yeah, that's right. There was a little meso-low in the NMS simulation as well. I don't know if how predictable these are. But I imagine this is some kind of an orographic effect causing that. I don't think the low was actually moving over there, but probably interaction with the mountains. Notice over the land, the winds are just light. So this flow from the larger scale circulation is all being channeled up here, and that's piling the water up against Venice. So just go through that. We'll go through the week here.
Where do you want to go then?
And go ahead to another, just animate it. You can just look at how these winds are coming and going over time, at least in this prediction. Maybe I'll experiment with getting the actual analyses. And see, they go away, and then the next system comes in, and before it can recover, they're building up again. But we really need to do this with the analyses to see what's actually happening, because these are model runs. But I think it gives you the idea, the gist of what is actually happening. These flows are funneling up there. And the other thing I wanted to make sure you understand is that the reason this happens is because of this Socorro wind being very warm. And the reason the very warm wind is so important is because it traps the boundary layer and creates these frood numbers that are so large that disallow flow from going over the mountains. And so they have to go between the mountains. And that funnels these cyclonic circulations into a narrow channel, which creates the medial tsunami.
I wonder if we could do, if we were to stop the animation, maybe go to a single image. Could we do a vertical profile, see the sounding? I don't know if the soundings work over Europe. No sounding
Maybe
data.
we could.
No, it looked like, but this perhaps not. It says no sounding data.
Yeah. That would be.
That's the analyses.
So let's look at analyses.
Look
Okay.
at how strong these winds are down here. You know, they're speeding up 30, 40 knots. And this is really where they're converging.
I think that's different models of the totality at the same time.
You know. So anyway,
Oh, great. You have this dry air that's trapped in the boundary layer, marine boundary layer. It's coming up across the Mediterranean then.
well, it's not dry anymore. In the marine boundary layer, it's moist.
So it's beginning to moisten up. So is there a component to any of this flooding from significant precipitation up along the Alps
There could
and
be.
other mountains?
Yeah.
Then the runoff.
This, besides creating a medial tsunami in the Adriatic, these flows also create extreme precipitation at the end of the channel. So up in Friuli and Friuli up around in here, up in the Alps, sometimes this wind will come up and rise up there, and I think there might be some extreme precipitation where you will get 5, 10, 20 inches of rain in a short amount of time. Then you get flooding up there from that. So this type of marine boundary layer trapping of moisture is quite important because it basically creates a inhibition to convection by the inversion on top of this layer that prevents extreme convection from occurring over the water. And so these strong winds will carry up huge moisture fluxes to these mountains at the end of the channel where it's lifted past its pre-convection level, and then it takes off and produces extreme rains. And so this, all these places over here, you get the same kind of thing happening over here in southern France and in northern Italy by Genoa over here. There's lots of places on the Mediterranean coast where this kind of channeled flow is like a fire hose aiming against the mountains on the shore, and it creates extreme rains. But it's only in the Adriatic that the flow actually builds up a lot of high sea level because of that channeling effect. So, that makes sense? All right, I'll let you finish with real weather here.
No, thanks.
That's real weather, right?
It's real weather.
You want Michael?
But I guess if we were to really look at this, we probably want to look at some spaghetti plots, right? For the forecast, Italy, spaghetti, anyway.
Yes. Okay.
Okay,
All right.
so let's first look at the satellite imagery visible over North America. And just a request, Pete, if it's possible to get imagery that's more zoomed in to this. Do we have that?
Oh, yeah, we got tons. It's not linked from that particular webpage, but if you go to the main AOS page, you probably want this one. You want black and white or color?
Black and white.
Yeah.
So nice. And of course, one of the things I was going to point out, it looks like, I don't know if in your class, the way you talked about it, it looks like some potential tropical disturbances just south of Mexico even.
We didn't have there's a tropical storm, I forget its name, and then an invest area.
Right, it's a bit smaller, to the east of us, south of Mexico. So the hurricane season is still active in the Pacific and the Atlantic. We have another couple weeks before it technically is over. But here's our current visible satellite imagery, the loop. And you can see a couple of interesting things. One of them was something we had talked about last week that we were expecting just off the East Coast, which was a developing cyclone. And we're going to actually look back at some of the analyses, or the forecasts that lead up to analysis for this particular weather event. Over the upper Midwest, we had a couple of snow events this week. One that was a little bit, also certainly frankly say under forecast earlier in the week. The midweek one was perhaps over forecast, but we've been anticipating a rather dry week ahead. And I think more or less that's borne out of it. But we got about a 0.4 inch of liquid equivalent precipitation over the course of this week. I guess being to our south. In fact, if you look carefully at the satellite imagery right here, you can see this band of the surface, this white area right here, which is not changing, and that's snow cover here. And you can see sort of southern Wisconsin, northern Illinois, eastern Iowa is experiencing some snowfall. It's still on the ground. And that snowfall goes all the way up to just south of Green Bay. So areas to our northwest perhaps have a little bit less snow. As you get further north with the conifers, things like that, I think some of the, you don't quite see the snow on the trees or around it. So that might be trees interfering with our ability to detect how much snow is up.
That snow shows up really good on the day cloud phase composite too.
Okay.
Which is a different image in this, but it shows up as bright green.
Right. So as you look at this map, again, relatively quiet. The most interesting area perhaps presently is this area of cloudiness. When we look at the radar, we'll see precipitation in this region, over the southeastern United States. Elsewhere, there may be still with these westerly winds, maybe some lake effect snow with the radar to really see that. But generally, it's quiet across much of the continental United States at this point. Let's go to the radar.
I'm going to bring up that day cloud phase and just show you. There's a 3-hour loop. Once it loads, all of this bright green up here is all snow. And back in the mountains back here, probably back over here. The light blues are lower liquid clouds and the yellows and reds are higher ice clouds.
Okay.
So anyways, you want the radar?
Yeah, radar. If there's something you'd like to look at, please just speak up. Again, that area of precipitation over Georgia and Alabama shows up quite well, and a lot of precipitation just offshore. But really not much, maybe a few lake effect bands and on southern Ontario, and some light precipitation across Maine. And the only other area, again, is you go way out into the western part of the United States, the Pacific Northwest, an area of showers and precipitation. That will play a role in our weather, perhaps on Sunday or early Monday, as that weather system passes to our north. But again, it's not expected to be a big deal. So we got another quiet week for us weather-wise. Let's first, before we go to the sort of look at the winds aloft and look at the find more page, go to the pivotal site for a moment. Take our analysis over the north of the continent. Again, you can click on, go back to national, and then click on continental United States. Go to the analysis and let us go down to, I should go to 6 hours because that'll fix some preset. And while I know we can do this, as you're just looping earlier, what I'd like to do, and we can scroll up a little bit, is just go back to the earliest forecast that we can see. Oh, this is loopable. Okay. So here is forecast from Sunday, 18Z on Sunday, valid for 18Z today. And we'll put back and forth between these. You'll see something really interesting. The fact that, again, in this week, even though we have a little bit more precip than we expected, broadly, you'll see that this forecast, 120-hour forecast, 5-day forecast, actually worked out, I think, fairly well. And it's kind of surprising. Not surprising, we know that we have the capability of doing that, but this was perhaps a very highly predictable week. 1009 cyclone located southeast of Charleston, South Carolina, and then just north of International Falls of 1032 cyclone. And if we were to just go back in time, can we go further out on this? So these are all valid at the same time, right? I think so. Right. So let's just animate this first of all. We'll see that there's very little change in the forecast. The final image here is the actual forecast time. So the model is kind of settling on a low off the southeast United States. We saw this even on Friday, and hinted at in the forecast. This broad anticyclone just north of Minnesota shows it pretty well, and the coldest air over the continent being just south of Hudson Bay. So I think this is, again, a remarkable 5-day forecast all the way down to the last short-term 6-hour forecast. This is something that I think.
Is the pattern fairly stationary? Is that why? Or I'm not.
I think it's not the stationary. We have weather systems that have been propagating across the country, but I think it's just been highly predictable. And I don't know if there's been a decrease in the number of tropical cyclones in the West Pacific that can sometimes disrupt our flow. But this is a highly predictable flow. Would we have known that a week ago? That's unclear. But we can certainly see from these forecasts, at least looking at one image at the final time, 60 this 6-hour forecast for today, valid 18Z. This did a remarkably good job. Again, there are certain details that are quite there. The cyclone is a bit more intense in the forecast, but you can even see as we get to shorter lead times, it does begin to produce a slightly more intense cyclone. The position of the upper trough, which we saw at the origins of that, were off in the Pacific, the southwestern part of the United States out of the eastern Pacific just a week ago. That was well forecast across over Mexico and emerged into this position. So, again, it's just an example of a really great forecast. So let's drive in all this. Let's go back to the super heats. And sort of 500 hectopascal. And at that level, we can see the upper trough. Again, we've seen this upper trough just a week ago, right out over the just southwest of California. And over time, it's been moving slowly across the southern United States, northern Mexico. And a couple days ago, actually merged with another trough that was in the northwest flow of the continental United States. So this really well-energized trough, surface cyclone downstream of it, somewhat favorable configuration for some further development of the cyclone. And we have this sort of split flow pattern where we're getting a confluence of a polar airstream, and I think there's a tropical airstream just off the east coast of the United States. With any baroclinicity here and this confluent flow, that's going to support frontogenesis, and in the entrance region of this confluent jet, we expect to see some ascent across the southeast United States, and that's partly the reason we're seeing precipitation there. Also, the changes in curvature of the flow from being cyclonically curved to this downstream anticyclonically curved in the ridge is broadly an area of divergence. In the middle of the troposphere, we'll see that's supportive of ascent and precipitation. Let's go to 300 millibars. Okay, and you can see nicely this jet, which presumably has some subtropical origins. Maybe we have to go further up to see how this connects with the rest of the flow, but you see this confluence of two jets, the polar jet and the subtropical jet, just off the east coast of the United States. This jet that's extends all the way to the western Gulf of Mexico is perhaps in part being supportive of, but also supporting this area of precipitation we saw on the radar just off the southeast coast. There's the convective elements here; those are certainly helping to drive. It's not really, I would say at this level it's not obvious, but let's go to 250 millibars, please. I'll see if this I can make the case or not.
Or not.
Way out for vision.
Apparently those images are not there. This is from the NAM model.
Okay. Doesn't show up quite the way. But we have this subtropical jet that's supportive of it, a small bit of it across the southeastern coast of the United States. But again, this is a pretty quiet pattern over much of North America. You saw those showers in the Pacific Northwest, again, downstream of this trough feature, which is somewhat expected. And so let's go down to the lower troposphere, 850 millibars, please. And here, in a very disorganized map in terms of barochronicity, there's no strong, obvious frontogenesis in the lower troposphere. You can see the cyclonic circulation over the southeast United States. Again, some weak warm advection across the Carolinas, and again, this broad cyclonic circulation, but it's just very, very quiet pattern. Not much temperature advection upstream of us. Then we have that really sharp front, so it's really cold. We'll look at the surface map in a moment over eastern Canada, and relatively mild to our southeast or to our southwest. We're kind of in this broad region where its temperature advection is pretty weak. Okay. Let us go to the surface map. And we'll go first to south, this will be good. So we can see southeast Canada, Ontario, temperatures here, 12, 18, just above freezing as we get into southern Ontario. And then to our southwest, temperatures are in the 40s, and we're stuck in this, with some snow cover that's partly helping to keep our temperatures down. Just getting to about 40 degrees today. But where the snow cover is a little bit deeper, it's still chilly there, 32 in Chicago, 32 in Rockford. Again, snow cover can have a big influence on our surface temperatures. But milder weather certainly lurks just to our southwest. But again, in southeastern Canada, that's where the really chilly areas, we saw that in the thickness maps in the forecast as well. If we scroll down to the southeastern United States, no areas of heavy rain noted in the east, Charleston, South Carolina, 54 to 54, kind of a cold, miserable day. That's not Savannah, but it's in eastern Georgia, 55 or 54, light rain. A lot of places with light rain. And then finally we get to Florida, it's milder, but it's kind of cloudy and not particularly pleasant, 75 over 71. Yeah, pleasant's all in the eye of the beholder, I guess, what you like for weather.
Looks good to me right now.
Yeah, I guess relative to our weather, but it's humid, 71 dew point, no one wants that. No one shoveling. It's better than shoveling, that's true. And if we just move back a bit, we can see not much in the way of any what I call interesting weather over the continental United States. Again, some showers in the Pacific Northwest, so it's all liquid precipitation. So we've gone from a pretty cold and active pattern to something that's a little bit quieter.
Alaska looks a little more normal.
Yep. Here, I think warmer much earlier. The last couple of weeks now, Alaska's back into the near zero in the interior, and then we get to Bering and the Bering Sea at temperatures in the 20s, but then 40s and 30s over southern Alaska. So not too bad. So what about the weekend that's emerging, that's coming up? And then we'll begin taking a look at Thanksgiving and look at some of the forecasts for that. And we look out getting a nice
is the flow going to be predictable? We can look at these maps now, we look at next week, and then eventually, week after Thanksgiving, kind of come back and do a post-mortem. For the weekend, so this is the current forecast. This is at 6 hours. Let's just go ahead to tomorrow morning. Our cyclone in the southeast United States still remains there. It's moved to the east. There's still also a lurking area of cyclonic geocircle vorticity just off of Cape Canaveral area, the Bahamas, not the Bahamas, but just off the southeast United States, a broad area of low pressure, but most of the precipitation is expected to be offshore. Again, the weather over the continental United States, I think John's timing was perfect, not be for weather watch today on a boring day. But again, much of the country is going to be precipitation free. We're in a region of strong warm advection, and so temperatures are going to be rebounding, maybe actually getting into the 40s for us tomorrow. Again, the snow cover is going to keep things down just a little bit, and the snow cover to our south is going to prevent us from maybe getting super warm. I don't know, Greg, you often talk about fog and things of that sort of, that's a big
We
concern.
haven't had much this year, yeah. We haven't had the Arctic system sitting over us with a southerly moist flow. We just haven't had that.
Yes, sir.
This one showed last Sunday.
This one last Sunday.
You look at the top right corner, it says initialize.
I think you're still on the model train.
We're still the model for this week? Thank you.
You have a single image.
I was looking at this thinking we were right. I don't even see where that is. Go to,
The top.
just refresh, single image.
Ah,
Single image.
like a header.
This cyclone is actually stronger, but still cyclonic circulation over the southeast and warm advection a little bit delayed. So neutral advection, but the strongest warm advection is going to be toward the east. Thank you very much for noting.
Yeah. Didn't even-
Because I kind of remember the cyclone was a little bit more intense to us. Well, maybe I just misspoke in times earlier. But again, the cold air is finally moving out of Canada, and we have this sort of warming trend over the eastern United States.
Is the origin of this cyclone what you're talking about last week that came out of Catalina Law?
Yeah, the one that was out over here. Yeah. And we can actually, we'll go back and we can look at that with Pete's maps. We'll do it just right now. Let's go, in fact, we can just do that. Pull this down for a second. Just to show you that loop. At 500 millibars on Pete's maps, you can go to the loop. This goes back a week, right, Pete?
Yes.
So I have to scroll up a little bit to see the beginning again. Is it the beginning? Okay. So this is last week, Friday.
8th, yeah.
So this is
Right.
embedded in the southern wave trend.
Right, so we had this, we had a cutoff, it was kind of cut off from the whole wave train. This feature, and there'll be another feature that comes to the northwest flow, kind of merge over the central and eastern United States. We just go forward a couple clicks. You can see this is finally on the move, moving into western Mexico. So Mexico right here. Of course, we lose the analysis there, and these begin to merge right over the southeast. You know, maybe the biggest part of this, if we go back a couple clicks, is this trough in here, but we have this feature here, and that one in the northwest flow that kind of merged over the southeast United States. So this was kind of what we saw in the forecast last week, and it seems to have verified pretty well. That's a tough forecast problem to get the linking of these two features on. Something that's a tropical stream and the polar stream merging. At least historically, it's been a challenging problem. This was one example where it actually worked out pretty well. Okay. So go back to pivotal, look at the surface map. Again, not much in the way of precipitation, but now with the right run up here, we can see a little bit of light precipitation over parts of Montana and western Wyoming. If you go ahead to 36 hours, cyclone really deepened. That's another 10 millibars of deepening offshore. So there's going to be a big concern in terms of hazards for strong winds and maybe beach erosion over, Cape Hatteras all the way down to just east of Charleston. Not safe to get in the water there, but most of the rainfall just offshore is really nice, intense low. And we are now certainly in warm advection by the time it gets to tomorrow.
Given the lack of a real cold air mass there, does that have some tropical characteristics?
It is warm core. We can go to the Bob Hart's page to see what the cyclone phase diagrams are suggesting for the evolution of this. So it would be FSU Bob Hart cyclone phase would be my search.
You just had it up there.
And 42. So the cyclone in A's at the beginning of this, Z's at the end of the cycle at this point, a week ahead. And this doesn't really move it much, move into the warm core symmetric until a little bit later on. Can we scroll down just a bit? Let's see the other. This is lower tropospheric thermal wind versus upper tropospheric thermal wind. It's kind of in this, depending on how you want to look at the diagram, it's in this very gray zone, close to the center. But it starts off as a cold core deep low, that's the upper trough is all the southeastern United States. Migrates to kind of neutral and then maybe shallow warm core in their diagnostic. So something to watch, but I don't think that, and maybe NSEP or NHC is not really going to be interested in this too much. Go back to pivotal. Let's go to 48 hours Sunday morning. You see that cyclone deepens it further, another 5 millibars as it moves offshore. And our warm advection is continuing into Sunday morning. This model, the GFS is forecasting some light snowfall and mixed precipitation in the northern half of our state, and maybe some showers to our south. We're kind of in this neutral zone of precipitation. The east WF from last night actually paints a different picture with a much broader area of snowfall getting down to just south of Madison on Sunday evening. So that's something we're going to watch, because you can see the trough associated with this approaching feature. So the Kelvin cold front south of it, you can see the cold advection just to our west at this point. And so this would be just
You notice
showers.
at the same time off the coast of Mexico, Baja, there's 2 tropical cyclones developing.
Right.
And this is coincident with the breakdown of the Walker circulation this week.
Okay.
The Walker circulation has almost completely disappeared. And instead, all we can see in the high pattern are propagating Kelvin rates.
So, and this suggests that maybe a week or so after this time period, so a week and a half from now, we might actually be able to see the Caribbean beginning to open up.
Well, I haven't thought about that, but it could. I don't know if there's enough warm water there right now, but there's certainly enough warm water off of the west coast of Mexico and Central America where it's going on. And but I think it's just indicative of how the global pattern is shifting. And I think what's happened is we've reached the end of an MJO cycle in Asia, and that's caused the Walker circulation to more or less disappear. And we see these periods every few months or every few weeks where the Walker circulation disappears and all we see are propagating Kelvin waves left over.
And so the key point, I guess, the takeaway here is that, so you have this region of ascent associated with these Kelvin waves or support divergence aloft that's been moving across the Pacific.
I think normally, in a normal situation, you have suppression in the Atlantic and the East Pacific. Overall subsidence with the Walker circulation, creating rising motion over the maritime continent. And when that breaks down, you basically lift the lid off of anything. So if other things are happening that are conducive to tropical cyclones, they can develop. And that may be partially why this storm on the East Coast is doing so well right now. I think if we were in a normal period of suppression, it may not be able to develop quite as well as that's doing.
Yeah, I mean, the point you made about, there's nothing, I mean, the upper trough has certainly been a key part that's helping to force this, but that's getting eroded over time. And so maybe over time, this could actually eventually spin up into something more subtropical. The environmental conditions aloft are still appropriate.
But we see this happening all the time when the Walker circulation breaks down. And we should, in my view, when you're looking at weather maps like this every week and we're looking ahead, we should be keeping track of what's going on with this Walker circulation and these east-west circulations, because they're very important. There's a lot of research right now that's showing that extratropical weather is modulated by something like an MJO cycle. This is basically the realization of that. And so I think we should be paying more attention to this, but all the way these things just start erupting in these periodic episodes like this.
And it might be a link also to predictability.
Yes,
right? Because we just entered a period that's been highly predictable, and the question is, will that persist? Maybe if you have these propagating waves in the tropics that are generating convection, the influence of that convection with the tropical and polar jets can lead to
Yeah.
more complicated flow patterns that might be more unpredictable or less predictable, greater uncertainty. So that's something we can try to figure out what are the appropriate diagnostics, maybe early next fall, spring, we can bring those into our discussion.
Yep.
So let's go to 60 hours, 72 hours. And that cyclone continues offshore, but sort of breezy conditions over the eastern part of the United States. The cold front that was to our west has now passed through us, so Monday should be a slightly cooler day. Again, not much in the way of precipitation. Let's go ahead
and
tonight.
notice also at this point,
Yeah.
the cyclone off the east coast has grabbed onto that direct link zone.
Right, so it's beginning to
It's,
get
its
wavier.
circulation is pulling a frontogenesis process to its west together. And now it's obviously driving a lot of its energy from the old direct link overturn.
Right, and we can also say that, and as this happens, we're also getting really deep in the trough to its west. We have this next weather system approaching, so there might be a nice favorable interaction between that surface. Let's just take a look at that. We go 96 hours at 989, we'll catch it, and it probably just did, just off the map, but this is certainly lower than 989 hectopascals as it actually gets the trough, so it's becoming much more robust cyclone once again, with snow over the Canadian Maritimes and eastern Maine. But for us, still quiet, not much in the way of precipitation. And we'll just jump ahead to 168 hours. I'm not going to go step by step on this. We'll get colder by next Friday. Maybe I should have gone step by step, but I want to quickly get to, in the few minutes that are remaining, look ahead to a Thanksgiving period. So before we leave this map, let's scroll down. Let's go to the total precip over the next week. Okay. This band right here, I'm going to actually ask you to go back to 120 hours for a second, because we did miss something. I want to make sure. And 72 hours, sorry. So as we get the frontal patches, a little precipitation, and then we go up to 168 hours, even more. So things are going to get a little bit wetter for us in the week ahead. And finally, if we go to 384 hours for the total push, southeast gets wet again. So what I'd like to do is go to 12Z on the 28th, which is Thanksgiving Day. And do something I like to do every year, and that is begin collecting, looking at the forecast from, so go a little bit more. So this is, and let's go to the surface map. What will be Thanksgiving morning. And if this is to be believed, again, if you're in the Twin Cities area, that the mixed precipitation, but sort of strong warm advection. The temperatures at this time on Thanksgiving morning, if you go to 2-meter temperature, yeah, probably just about freezing or so, a little bit below freezing. And sort of freezing rain maybe in the Twin Cities area. We'll go back to the surface map, and let's just look at the series of forecasts. Overall, the earliest one we can get, I think, is going to be 18Z on Sunday. Valid again, 12Z to 28. Just look at how the forecasts have changed somewhat. So this was, nope, didn't work out. Sorry, go back to a current map. 12Z to 28. So we go, click on this, and let's just go to Monday, 6Z forecast for Monday. Let's make sure we keep the map at the same time. Still not going to do it. 312 or whatever this is. I mean, it's 12Z on the 28th. What's the latest forecast that we have? Valid at 12Z on the 28th. There we go. That's today's. All right, let's just keep going. Let's go back in time. Still valid. Okay, so it's 360. We can go one more 24-hour period after that. All right. So, yeah, that's 60 on the, okay, so 60 on the 28th.
But you can go forward 6 hours.
Go forward 6 hours. And there we go. That's 18. That's fine. That's fine. I'm not gonna get any better. So, this is a forecast valid for Thanksgiving morning. This will suggest just a very messy time period for everyone that's arrived at their destination by the time that Thanksgiving is starting strong warm convection for us, snow going over to perhaps rain. If you look at forecasts that were initialized a little bit later, just give it the time, you can see this just flips to something totally different with this cutoff low that's well to our south, and we have this big coverage over the southeastern United States. Let's go ahead and just another forecast period. Or we get cold advection. Again, you can sort of take your pick on what you want to see weather-wise for this time period. But if you go back even further, or go forward even further, not time-wise, but just forecast like
saying you're looking at different times, this is 60.
I'll collect the maps, and maybe that's probably the easier way to do this. So this is, go ahead again.
Go ahead, let's show 0 Z.
Something powerful with this.
That's 12, 7, 20.
Okay, so for this, we should be able to go back to 12-hour increments, going back, and we should be able to see the same time and after adjusting. Yeah, it's totally on 20. So we went from cold advection to sort of neutral temperature advection at this point, but still generally dry. All the interesting weather back over over Colorado. Let's go back another 12 hours. Okay. That's that big ridge. We saw that solution before. Again, I want to go toward earlier times. I can go back and you just go.
I'm not sure what you mean by earlier.
Wednesday, the 18 Z forecast initialized Wednesday 18 Z. Or 0 Z, that's fine. Cold advection. Let's go back a little bit closer to real time as yesterday. Morning's forecast. Again, a little bit of light snow. Again, valid 12th, Thanksgiving morning. So you can see that there are lots of different solutions that are emerging for Thanksgiving Day. Again, it's still really far out.
The one, the old rule of thumb.
Yeah.
That you always look at is that the isobars in the warm sector are the direction the storm's going to track.
Right.
Right. And so what I'm seeing with all these storms is a very strong north to south isobar pattern.
Mm-hmm.
And it seems that most of these storms now are starting to track more toward western Wisconsin, and we're in the warm sector. And that's not good for snow.
Right.
And so we seem to have shifted in the past week to a new pattern, where the storms are going to start tracking to our west.
Right.
And I'm not sure what's causing the shift.
We just subtle change in location of the upper ridge to our west and the downstream fall. We just go the last few forecast cycles on this. And then we'll call this a day 0 Z. Again, much more intense storm, but to our west. And then 0 Z, dry, that's warm advection.
Still changing the time on me.
It's still 0 Z, I told you on the.
I just changed it to.
Okay. And then we get to this. So what I'll do is I'll collect these images so that we can look at a whole loop of them, going back as far as we can with consistent dates and just step through them. Kind of interesting just to see how the forecast will evolve and getting a sense of when do we eventually lock on to what the pattern is going to be for Thanksgiving Day. But for the short term, a few showers tomorrow night into Sunday morning, rain and snow showers, getting cooler on Monday, and then the week ahead looks gets somewhat unsettled with some precipitation and getting maybe sharply colder Thursday into Friday. So that's it. Pretty quiet weather forecast.
I'll just point out, I think part of this is the existence of that. That's creating this strong isobar pattern between the low and the high, that's
Right.
north-south. And that is going to steer the low westwards. And I think before, earlier in the season, the high was tended to be further north. And and so the low was being cycled more south of it. But I think it's being steered away.
I'm wondering, you want to go to the east of this, or is there something upstream that's helping us up the pattern? I don't know.
It's all connected.
It's all connected, right, that's true.
But yeah, I mean, I'm looking at these and last week when we were looking at these, or 2 weeks ago, it's always looking like the low is going to track to our south.
Yeah.
And now it's obviously not going to track to our south in every single picture we look at.
So yeah, this
For
suggests
forecast.
generally a milder weather pattern for us coming up.
Yeah.
And if you were to look at, one last thing, if you go to the winter weather products at the bottom, winter weather, and then to snow depth anomaly. You see by the end of this period, it's a 312 hours. So by the time we get to Thanksgiving, we're gonna have eroded a lot of the snow cover that we have right now. If you go back to the 0Z, the initialization, what the snow depth anomaly is on this, you can see largely lots of blues in here. A little bit, this is kind of close to normal, and then it's certainly far below normal over the western part.
Yeah, but look it up at Canada there,
Yeah.
and Quebec, I mean,
This will play a role in helping big ridges develop over southeastern Canada, and maybe occasionally these backdoor fronts that will slide to the south. I would say that pattern probably is going to be more favorable for icy conditions for us later in the season if it persists.
yeah, that's quite anomalous, though, isn't it?
Yeah. So
Yeah,
dearth of snow here, increasing snowpack here. If you want a really cold winter, you want to see these areas much bluer than they are. But again, this is a forecast. This is not the analysis at this point. That would suggest that as we go into December, we'll probably be above normal.
Assuming the anomalous snowpack is going to be, the AMS travel is going to be really, really fun in January.
Could be. It could very well be that. Right. If you truly want to go that far, again, this is now just more for fun. Go to the CFS.
Nobody's going to make it. to
Slightly
Boston.
Right. So we're looking now middle of December, again, if you really want to believe anything like of this sort. But I mean, just extreme amounts of snow in eastern Canada by that time period. It's not colder, across much of the northern, or not colder, above normal snowfall over much of the northern part of the United States. The temperatures aren't too bad. Yeah, all right.
thanks.
Thank you, Pete. Thank you, Greg, for taking us to another part of the world and looking at the conditions there. That's great. And you guys have a nice week. See you next week.
Okay, 141 class, 10 minutes.